Hello everyone, welcome back to another video with Mr. Coder, and in today's video, I'm going to show you how to solve Cherry Bomb, question C from Codeforces Round 1020, Division 3. So, you're given two integer arrays A and B of size n. They're called complementary if there exists an integer x such that for every I from 1 to n, it holds that AI plus BI is equal to x. For example, 214 and 341 are complementary since 2 plus 3 equals 5, 1 plus 4 equals 5, and 4 plus 1 equals 5. So they all are the same. But 1, 3, and 2, 1 are not because 3 is not equal to 4. So Cal the Nerd, which as a fun fact, that's actually me. I'm friends with the author and he decided to include me in the problems. So that's actually me, what some people call me in chat. But yeah, everyone is that he basically put that I thought everyone was interested in math, so he gave Cherry Bomb two non-negative integer arrays A and B, which are complementary and of size n. Every element in A and B is at most k. So that's a very important fact. Each one is at most k. Unfortunately, Cherry Bomb has lost some of the integers of B, and lost elements of B are denoted with -1. Help Cherry Bomb count in how many ways he can replace the missing elements from B with non-negative integers not greater than k, so between 0 and k inclusive, such that the arrays A and B are complementary. So as you can see in this first test case, 1, 3, 2, -1, -1. So the only way to do it is if this one's 0, this one's 2. So in this one, there's no possible way because at starting off, 1 plus 0 equals 1, 0 plus 1 equals 1, but 0 plus 0 equals 0. So no matter how you set these -1s to be equal to, it'll never work. So that's when you notice for this type of problem, it'll always be it'll always be 0 or 1 if there's at least one I such that AI and BI are both not -1. So as you can see in this is something you should always check the sample outputs. Notice how there's only one of them that aren't 1 or 0. So that's the fourth test case, which is right here. And notice what's different about the fourth test case compared to all the others. They're all -1. So that's when you have to choose all of them. So that's what makes you should think that if there's at least one that isn't -1, then you should manually just check if it's possible in the first case, because otherwise then it would have to be 1. Otherwise, if it's all -1, you have all the flexibility in the world, so you can make sure that all of them would be between 0 and k. So using the maximum and the minimum of A, you can calculate that. So as I did in my code here, so I just inputted the arrays and then I got the index and I tried checking if there's any index in B such that it's not equal to -1. That means that there's already a fixed sum in the array. So that's the array that's the index that I want to check. So if it isn't equal to -1, that means that this target sum is A of IDX plus B of IDX. So the index, and I need to find the total. This is just basically the total amount. And I just update it to 0 if it's doesn't work, so then I can just print it out directly compared to having a Boolean. So I just loop through and check if A of I is greater than the sum, then it's always impossible since B of I has to be a non-negative integer. Uh, Otherwise, if B of I is not equal to -1, which means that they're both already fixed, and A of I plus B of I is not equal to the sum, it also doesn't work. But also, if sum minus A of I is greater than K, then it also doesn't work. So those are the three cases that will make this condition false. So if any of those three conditions are met for any index I, then you print, then it's 0. Otherwise, it's 1, since there's never going to be more than one possibility, since there's only one sum. Otherwise, notice that like you can get the minimum and the maximum, and it's just the k plus the minimum minus the maximum plus 1. So that doesn't make sense to you. There's k total numbers, and then you want to subtract the maximum then you're gonna add the minimum. So how you basically come up with that by like looking through the cases. So if you look at this one right here, it's 7, and that's because the number 4 or the number 1 here, it can be matched with 10. So that's the maximum it can be. So 1 and then 10. But then the maximum, it can't be. Then you also do it from the maximum since it can't be any less than the maximum. So the maximum is 5 in this case. So it can be from 0 to it like this one can be from 0 to any of the other one. So in this case it'll just be k, which is 10 minus the minus the maximum plus the minimum plus 1. So yeah, that's basically how you notice that k plus the minimum is just uh it's just 10 plus 1, which is 11. Subtract 5 and add 1. That's how you count all the numbers. How many numbers are there from 5 to 11? So that's basically how you deal with all negative ones. So it's basically just sample case handling. So you basically need to check the samples to determine if you can find any patterns and like utilize the samples to your advantage. That's basically this problem. You need to check the samples and then you can work stuff out on paper a little bit or just in your mind. Because if you're able to solve like these cases, then you make it broader to work for a generic case, then that's how you solve a problem. So that's the key thing, since it's not straightforward necessarily how you do this unless if you actually calculate it. So and then this part is just checking it. So and it's just easy to prove that there's only a maximum of one solution because for any one sum, there's only one number that can be added to another number that can equal the sum. So that's just a property that's of addition. So yeah, that's how you solve Cherry Bomb, question C from uh Codeforces Round 1020, Division 3. So yeah, thank you for watching this video. If you like this video, please like and subscribe, and I'll see you in the next one. Bye.